All right, so this is where we concluded the session yesterday. I was explaining that Google has the largest network of its kind, and how Google has the largest network, or how Google has an edge when it comes to network infrastructure, because Google has its own undersea water optical fiber cables network. Google has its own network infrastructure that Google leverages to deliver networking and content delivery services to customers across multiple geographies. That's how Google is different when it comes to the networking. Now, participants who have some knowledge of AWS and Azure networking, when we provision the network in Google, you will see the difference that how it happens in the world of Google. You can see here the entire world is connected via Google network, or Google has a high throughput network which is connecting majority of the locations in the world where IT happens. So this is your United States. The entire United States is connected. You can see here, this is South America, this is South Africa, this is your Europe and Russia. This is where you have India, this is Asia Pacific, this is Australia, and this is New Zealand. So Google is well connected. Google has a well connected network, which basically means that if I host an application in one of the Google's region, in one of the regions that Google offers, my application will be accessible from other locations, or if I have services configured across multiple regions, those services can communicate in Google backbone network. So the traffic between those services will never leave Google network and go to the internet. For example, if you have a compute engine instance in America and the other instance is hosted in India. Now, when you are trying to copy some data, or when those two instances are communicating, the entire traffic between these two instances will remain within Google backbone. It will never leave Google backbone network and go to the public internet, which is untrusted. That's the benefit of this network. These are the locations where Google has its data centers, or Google has its regions: North America, South America, Europe, Asia, and Australia. Now, how do we define it? First of all, let's see the numbers. So I'll show it from my own presentation. So these are the numbers. First of all, I'm saying this presentation, you have information about all the three major cloud vendors. That starts with Microsoft Azure, that starts with AWS basically, because AWS is the first company, or Amazon is the first company that launched cloud services, or that launched cloud computing business. So it started with AWS back in 2006, and after AWS is currently the #1 cloud service provider also, and then it basically expanded to Microsoft. After AWS, it was Microsoft who basically started providing cloud computing services. And prior to Microsoft, and after Microsoft, it was Google Cloud. Okay, I don't know why I don't see AWS here. Sorry, AWS is there. However, Microsoft is missing from this. That's okay. So then it was Google Cloud. Now, Google basically started cloud, or Google came into cloud computing business in 2012. I'm saying Google had been offering PaaS services, some of these services which Google categorized into PaaS domain since 2008. However, I'm saying you would not call them cloud services because they were Google apps. So Google apps, Google was offering. It came into cloud IaaS market, which is the most popular product in cloud computing, infrastructure as a service. It came into that market in 2012. June 2012, they launched Compute Engine Service, and that's where Google was officially known as coming into cloud market. So as we speak, Google offers IaaS virtual machines, App Engine. It offers serverless computing in the form of Google Cloud Functions, Cloud Run, Google offers object and file storage, which is GCS bucket. And Google has multiple regions across United States as well as presence in Belgium, Japan, Singapore, Germany, the Netherlands, UK, India, Australia, Brazil, Canada. I'm saying all the regions. And these are the strength of Google. Now, this information has been taken from Gartner's Magic Quadrant. Gartner is a well-known name in the industry that provides Magic Quadrant or that provides analysis or that does survey and then provides an outcome of that survey in the form of Magic Quadrant. So Gartner basically put AWS at the on the top or at first place. Microsoft comes at second, and Google comes at third place. Now, this is how Google's global infrastructure is spread. So here in this presentation, you can see Google as we speak. Now, this I only updated yesterday. So as we speak, Google has 40 launched regions. Now, every time I'm delivering a training, I will have to update this presentation because between two trainings, there is typically a gap of 15 to 20 days. And within that gap, a lot changes in Google or in any other cloud. That is why no presentation is up to date. And that is why for critical things, you should always refer to OEM documentation because you will get up to date information on the documentation. Even if you don't get up to date information, you will not be blamed for providing outdated or incorrect information. Because you can always say that this is an enterprise product or this is an OEM product, and I referred to OEM documentation. So while you are supporting customers in your respective business unit, whether it's platform ops, database ops, cloud ops, SecOps, always provide OEM documentation to your customer as a reference as part of your service request or incident management. Never ever share third party information. Your customer may get offended, or you may end up sharing inaccurate information, outdated information with the customer. So Google has 40 launched regions, each with multiple availability zones. I'll talk about what zones are. 8 announced regions. So Google has announced these 8 regions. Now you never know, probably tomorrow, day after, or next week, one of these regions will go live. Then the total count will increase by 1, which is 41 launched regions. 121 zones, 200 plus countries and territories it served, 187 network edge locations. These network edge locations are smaller data centers of Google, small data center from where Google is providing some of its cloud services, one of them being CDN services, which is the same case with other cloud service providers. Now, this is how Google is spread geographically across the globe. You can see Google has a good number of regions in United States and Canada. Google has a lot of regions in Europe and Russia also. Google has regions in Asia Pacific, which includes India, China, Singapore, Malaysia, Taiwan, Japan. Google also has regions in Sydney and Melbourne. Google doesn't have a region in New Zealand. So if Google doesn't have a region in New Zealand, and if there's a business in New Zealand who is willing to host workload and applications in Google Cloud, that business can actually use one of the regions in either Sydney or Melbourne, one of the nearest region. So from New Zealand, the nearest region happens to be either Melbourne or Sydney. So they can basically provision their workloads and applications in this region, and they can have them uh, made available to their end users across the globe. And you can see Google is also opening a data center or a region in New Zealand. So probably soon Google will have its presence in New Zealand also. Now, what are these regions? Regions are independent geographic areas that consist of zones. Regions basically means a geographical location. For example, Delhi, Mumbai. Google has 2 regions in India, one in Delhi, the other in Mumbai. Or in US, it has one region in North Virginia. North Virginia is a state which sees most of the cloud service providers primitive regions. or you can say most of the global cloud service providers, they start with North Virginia. Why? Because the government policies or the Virginia state policies are favorable for cloud service providers to start their business from there. So you will find Azure has a region in North Virginia, AWS has a region in North Virginia, Google has a region in North Virginia. So you see multiple regions here. They are geographic locations. So when I say geographic locations, it doesn't mean region stands for a country. No. In a country, there can be multiple regions. For example, in US, you can see there are 7, 8 regions in US. They are geographic locations. Then comes zone. Now, what is zone? I will explain it from the official presentation. So this is about Google Global Infrastructure. If you want to see it on the official documentation, just click on this hyperlink. It will take you to official documentation. So this is OEM documentation wherein you will see the same information that it has got 40 regions, 121 zones, 187 edge locations, 200 plus countries and territories it is serving. Now, when I say 200 plus countries and territories, what does that basically mean? It basically means that if there is a country or a territory that does not have a Google region, businesses from that country and territory can actually use a nearest region of Google to host their workloads and applications. That is how this number is coming 200 plus. Otherwise, it's only 40 regions. So that's the logic behind this number. If you look at the network, look at the Google network, how it is spread, you can see the network. So it says submarine cable investments and current network. Now here you can see Google has the entire world connected with its network. And the one that you see in green, this green one, this is submarine cable investments. So Google has its own, undersea water optical fiber cable network that it has deployed using submarines, and Google is managing all of it. So the entire communication you can see from United States to Europe. There is no road network. There is nothing in between. It's all water. It's all sea. So what Google is doing, Google is putting that underwater optical fiber cables through which it is connecting these, and it is also using the other methods for connectivity. So this entire network that you see here, this entire network is fault tolerant, which means there is not one connection. There are multiple connections, and if one connection goes down, the others will continue to work. There was an incident that happened in 2021 wherein a whale, which is a largest sea animal, a whale basically, while moving from one place to another, the whale got stuck into the submarine, into the optical fiber, cables, and it broke that cable. Basically, the cable got partially broken, because of which there was an outage. There was a global outage of internet. However, the customers of Google did not suffer from that outage because Google had its own separate cable network, optical fiber cable networks. Through that network, Google ensured connectivity to all the customers. So that's how Google is very strong. You will not find similar image on Azure and AWS global infrastructure page. Okay, if you want to see the products, that what all products are available. So these are the products. Google has more than 200 plus products and services that it offers from its data center. And you will notice that not all products are available in all the region. For example, Google Cloud VMware Engine. VMware and Google Cloud Service is not available in, when it comes to Americas, it is not available, in Oregon, but it is available somewhere else. For example, bare metal solution. It is only available in Los Angeles, not in other regions. So when you look at the services, let's say I want to see Cloud Run service, in what regions Cloud Run is available. So I can just click and say, I can just be on that page where it says Cloud Run, and I can look for Asia Pacific. If I want to check whether Cloud Run is available in Delhi, yes, it is available in Delhi. Cloud Run is a serverless container service. Using Cloud Run, you can deploy containerized applications in the serverless module or in the serverless mode. So this service is available. Similarly, there are other services which are not available. For example, this service, you can see Artifact Registry, which is a DevOps service from Google. This service is not available in Delhi. It is available in Mumbai only. In Asia Pacific, you have Mumbai, Delhi, Singapore, Jakarta, and other regions. So service is not available in some of the regions. So this is what you need to be very careful when you speak with your customer. If your customer is willing to leverage or use a service, you must look into this page and check whether that service is available in customer's region. If not, please inform the customer then and there. Otherwise, when you inform it at a later point in time, the customer will feel that you're not a good consultant or you're not a good vendor. So this is how you check all these services and region. Now, Google also provides, so these services that Google provides, they can be categorized into two brackets or two main categories. The first is global service. The second is regional service. Any service that is limited to a region. For example, compute engine instance. Compute engine, when you provision it in a region. It's a regional service. But Google also has global services, global products. Global services basically means any service that is globally available, or you provision that service and then you can leverage it across the globe. For example, load balancing, CDN, cloud network, VPC, virtual private cloud. You provision a VPC, you can expand it across the globe, you can further segment it into multiple subnetworks, and you can build those subnetworks across multiple geographies and regions. So these are your global products. These services are available across the globe. Coming back to the presentation. So this is how we define region, zones, and location. Location basically means geographic location, which is North America. So North America is location. Region is North Virginia. In North America, so North America is the location. And if you say region, it is North Virginia. In North America, you have a region with the name North Virginia. Then comes zone. Zone basically means understand this image and it will be clear. People who are from Azure and AWS background, the concept is same. Availability zone, you will also have it here. So what happens in a location? There are multiple regions. For example, in Americas, there are 8, 9 regions of Google. Now this is showing one region. So in the square, there are 4 regions. This is just highlighting one region. Then inside a region, now this is the region, there are multiple zones. Zones basically means collection of data centers. So Google is not building one data center in a region. There are multiple data centers. They are connected, they are redundant, and they are independent at the same time. They are redundant because they are connected via high-speed optical fiber cable network for the purpose of data redundancy. And they are also independent because damage or impact on one data center will not affect the functioning of other data center. So data centers are both redundant and independent. That arrangement is known as availability zone. Give me a moment. So this arrangement is known as availability zone. Now here's the example. You can see it says regions contain multiple availability zone. For example, London is a region, right? Now London region is part of which location? Which location it is part of, guys? London?
Europe.
Europe. So Europe is the location, London is the region, and in London, you have multiple availability zones. So London is denoted by Europe West 2. And in London, there are 3 availability zones, West 2 -A, -B, -C. So availability zone or zones are denoted by small case alphabets, A, B, C. Some regions have 4 availability zones also. 4 is the maximum in Google Cloud. In AWS, you have up to 6 availability zones. In Azure, you have not more than 3 availability zones. So when you have more availability zone, it directly means that you have more number of data centers in that region. That's the concept. Okay. Now it says zones are where cloud resources are deployed. So inside zone, you deploy the cloud resources. And you can see here it says resource redundancy. So zone is actually providing you the redundancy that you need. So how it provides the redundancy, let's understand it from here. Okay. So let's say this is my region. Let's take this is Europe region, EU region. In this region, we have 3 zones. So we'll say zone 1, zone 2, and zone 3. These are the 3 zones. Inside zones, we have data centers, and a minimum of 2 data centers are there in each zone. So let's say this zone, this is A, this is shown into small case letters B and C. These are the 3 zones. Now inside zones, we have data centers. So this is my first data center, this is my second data center, and this is my third data center. Similarly, in zone B, there could be a minimum of 2 or more than 2 data centers. Let's say there are 2 data centers here. In zone C, there could be 4 data centers also. Now, this information is hidden from the customer. No cloud service provider will share this information with the customer that how many data centers am I keeping in a specific zone. Cloud service provider will tell you how many zones are there in a region. So this is how the architecture is. Now, how this architecture will help you. Let's say you want to deploy an application, a highly available application, a 3-tier application, a 3-tier application that has 2 web servers, 2 app servers, 2 database servers. So what you will do, you will, when you deploy the application infrastructure, the first web server you will deploy in this data, I'm saying in this zone, zone A. So that has your first web server. This is your first web server in zone A. When you deploy the second web server will go in zone B in one of the data centers in zone B. So this is your second web server. So your first web server resides here, second web server resides here. Now, what is the benefit of it? The benefit of this approach is that both A and B are independent and they are at a maximum distance of 60 miles. I'm saying they could be at a distance of 10, 15, 20 miles also, but the maximum it will not go beyond 60 miles. 60 miles is like 80, 90 kilometers. So these both availability zones, they have independent source of power, independent source of network, and they are at a very reasonable distance. So the same trouble, same impact cannot affect both these zones at the same time. So if there's a power outage here in this zone, there the other zone may have uninterrupted supply. The same outage will not spread to the other zone. So which means that if this zone goes down, this VM will go down, the other will continue to run, and this other VM will continue to uh, continue to accept connection requests from users or continue to serve your application. That's the concept of zone. Now imagine if zone was not there, and if I was not using the zone concept, I was just deploying my servers. So let's say I deploy my first web server. Let's take the example of zone C. Let's say zone is not there. This is just one, this is the region. This region contains multiple data centers. There is no concept of zone. Now what will happen when I deploy my first VM? It gets deployed here in this data center. When I deploy my second VM, it may also get deployed in the same data center, because you don't decide, you don't select the data center. You just select the location, the region that I want to deploy in US, in North Virginia. Where in North Virginia, which data center, you don't select. Google decides it in the backend. So what if Google puts both the VMs in the same data center, and imagine this data center is experiencing a network outage, a power outage. What will happen? Your both VMs will be down, your application will be down. So to provide redundancy and fault tolerance, we use the concept of zone, which will spread our resources across data centers which are connected as well as independent. For example, all these 4 data centers that you see in a zone, they're connected to one another through optical fiber network, which means if you store any data here in this data center, multiple copies of that data will be created and stored across other data centers. So at any point in time, if you lose some data, or if this data center goes down, if it catches fire, if there is any outage in this data center, Google will, and if that data is lost, you cannot recover it. Google will copy it from other data centers. So Google has made this arrangement just to make sure that the claim that it makes, which is highly available, fault tolerant, redundant, performance, all of those claims it can manage. So that's the concept of availability zone, or Google doesn't use the word availability, Google use zones. So that's the concept of zones, which is nothing but an arrangement of data centers in a group, and that group will ensure high availability and fault tolerance. So while provisioning instances, you will select the zone, whether A, B, C, and your services will be deployed in those zones. In fact, when you provision your network, you will select the zone at that point in time. So your network will define the placement of services or virtual machines that you will deploy in that network across zone. Any question on this, guys? The concept of zone. Yes, no, maybe. This is one such topic that not will have good clarity on. And since they do not have good clarity, they're not able to design highly available, fault tolerant, and redundant and global applications because they are not well aware of the concept of zone, or they do not know how to leverage this concept in the design and architecture. Okay, so regions contains multiple zones, and zones are where cloud resources are deployed. So it doesn't say that you deploy resources in data center. Why? Because that information is hidden from you, hidden from the customer. Google never says that I am using data center number 1 in zone A. Google says which zone you want to deploy, and Google decides the data center in the backend. Okay. Resources can run in different regions, you can see. So these are 3 different regions. You can deploy resources across the region. And if you do that, it will help you it will help you to recover your resources, your workloads and applications from disaster. Okay. Some services can run in multiple geographic locations. So you can run multi-region services also. For example, Cloud Storage Bucket supports multi-region. Google KMS Key Management Solution supports multi-region keys. So you can deploy resources in multi-region, which basically means either the resource has multiple instances of it deployed across those regions, or resource can be reutilized or can be referenced across multiple regions. So this presentation that you see, this is official presentation, which I only downloaded, downloaded on Monday this week. And you can see that they have not updated it because it used to be 39 regions until the beginning of this month. So they have only made one region live that made it 40, and that 118 became 121 because that region went live with 3 zones. So 3 is the most common number of zones, 4 is some of the zones. Okay. Then comes how Google data centers consume energy. You can see data center energy consumption is 2% of the world electricity. What it is trying to say? It is trying to say that businesses are moving to cloud, and that is why cloud data centers are hosting more and more resources, and as part of their functioning, they need more electricity. So 2% of the world electricity is being consumed by data centers. Now, Google, while building its data centers, it takes care of the environment. It thinks of zero carbon emission. It thinks of environmental, social, and governance issues. So it says Google data centers were the first to achieve ISO 14001 certification, which is about how how efficiently you build data centers, how efficiently you reduce the carbon footprints, how you adapt green energy concept. That's what it talks about. The cooling solution of the data center contains hardware needs to be kept at a specific temperature. To maintain that temperature you need AHUs or cooling system in place. So how Google is putting cooling system in place, you can see Finland, which by default remains cool most of the time. So Google is using natural resources to keep the data center cool, or to maintain the temperature in the data center at a specific level. So this is sustainability part, leave that part. Okay, then comes the security, which is very important. See, cloud is all about security. You will not realize, but you will slowly and gradually move into security. If you start to work in cloud domain for a quality number of years, probably 3, 4 years later from today, if you're starting your journey today, you will automatically move into security, or you will have good idea, good knowledge equivalent to a security professional. So Google has built its cloud data centers keeping security in mind, which we can say Google data centers are secure by design. Google follows the principle of security by design and privacy by design. So Google data centers are secure, and they also keep your information. When I say your information, it's customers' data. They also keep it private. How they keep it, we'll talk about in subsequent sessions. So Google is putting a lot of security controls at each layer. When we compared between IaaS, PaaS, and SaaS, I broken a data center down into its technology components stack, like hardware, network, server, virtualization, middleware, OS. Similarly, let's see how Google is maintaining the security at the hardware level. Hardware level basically means the physical hardware which Google has put into the data center, which is getting virtualized for the customer to have their resources configured. So for hardware security, Google is using the secure boot capability. In fact, your laptop, if it is configured with Intel 64-bit architecture, if it is recent, has i5 and above processor, you will find that it is also secure boot enabled. So what secure boot is, uh, there was a time when hackers, they become advanced, and instead of hacking into your network, instead of hacking into your applications or systems, they started hacking into your hardware. Hardware basically means they will put a spyware or a malware in the boot sector of the drive. And what will happen as soon as you turn your system on, whether it's a laptop, desktop, or a server, the malware will take over the boot process, and it will stop it then and there, or it will execute that process the way it wants to, which known as firmware level compromise. So to tackle that situation, what hardware manufacturer like Intel, IBM, Gigabyte, these motherboard manufacturer, they started using secure boot functionality. So with secure boot functionality, they quickly scan the firmware, they quickly scan the boot sector or boot drive, and see if there has been any change in the configuration from the last successful boot. So let's say you boot your system today, and you are browsing some websites, you get a malware, and that malware is affecting your firmware. Now, next time when you boot the system, the firmware will take over. So due the secure boot, what it will do, the secure boot will quickly see whether the file system, whether the configuration firmware is intact as the previous boot. And if it finds any changes, it will stop then and there. That's what secure boot is. So the booting, so it will boot your hardware or boot Google's hardware correctly to avoid any or to tackle any firmware or boot level attack. Then comes premises security. So Google has multiple layers of physical security protections in its data centers. And Google is using server boards, chips, and networking equipment, from custom designed by Google. It is like Google is not manufacturing its hardware. Google is getting it manufactured by a third party. However, it has shared some specific requirements. It's a custom designed hardware based on the Google security requirements. It's like customizing a hardware. You want to purchase a laptop, you navigate to Amazon or Dell website, and then you can customize the configuration. You can select what kind of hardware you would need and collectively select the components and in the end, build your own customized system. Same concept here. For service deployment, Google uses encryption. Encryption is a method through which communication between source and destination can be encrypted, or a plain text can be converted into a non-readable format, which is known as ciphertext. And using that technology, the transfer of data from source to destination and vice versa can be secured. That's what service deployment level. So when you are deploying services in Google, you are sending API calls. Those API calls are encrypted. So it cannot happen that you select a cloud storage bucket configuration and in the end, and as a result of that, and you execute submit, and as a result of which Google provisions a compute engine instance. No. Or Google provisions a bucket, but with a different configuration. That may not be possible because of encryption of inter-service communication. Identity level. Google does identity level protection also, which basically means that any additional factors or risk factors which are there, Google is managing it. So users can use secondary factor authentication. Google provides you a capability when you can configure MFA for your identities, which will ensure a second factor authentication or dual protection for your identities. Storage service level. So Google is using encryption at rest, which basically means when you upload some data into Google Cloud, your data will be by default encrypted at rest by using Google's own managed keys, own encryption keys. If you're not satisfied, if you want to use your own encryption level, you can use KMS service and create your own encryption keys and use them to encrypt your data. Even if you feel that encryption keys belongs to Google or the service belongs to Google, you can bring your own encryption keys from your on-premises hardware security module that Google also allows. Internet communication level, the entire communication that comes in and goes out is secured by Google frontend and denial of service. So any traffic, network traffic that comes in, from internet to inside Google Cloud Data Center or to your VPC network is front-ended by DOS and DDoS protection. So Google has a standard or basic DDoS protection enabled for each customer's project and account, and in fact for its own network. And if you want a detailed or if you want a deep dive protection, you will need to pay for it. There are services available. Same is the Google front end. Any traffic that goes out of Google data center, it is encrypted using TLS connection, which is encryption in transit, which is the highest level of encryption standard or encryption method for for sending traffic outside of Google data center. Now, any traffic that remains within Google network backbone, that is not encrypted because it's a trusted traffic. It is like when you step into your office premises, at the main gate, you will need to probably show your identity card or you will need to use biometric. But once you are inside the office, when you are inside the office, when you are moving from one department to another or one cubicle to another, you're not expected to authenticate all the time because you are a trusted resource and others are your colleagues. So you all can trust one another. That's the same concept here. When traffic moves from one region to another or from one Google service to another Google service, it is trusted by default and hence it is not needed to be encrypted. Encryption sometimes affects performance also. So imagine a situation, I'm saying you are in Hyderabad and you are on ORR, Outer Ring Road, or you are in Bangalore and you're driving on the expressway and you are driving at a speed of 100 kilometers an hour or 120 kilometers an hour. And then probably at the, after driving for some time, you see a police barricade, a barricading. Now you will feel bad about it because you're accelerating at 100 kilometers an hour. Now you will need to deaccelerate, put brake, and probably move very slowly at a speed of 10-15 kilometers an hour. And if required, you might need to park your car also and show the documentation to identify yourself who you are. So you will feel bad about it. What is that? Impacting the performance. Who, what is happening there? Security. Policemen are there, barricading is there to secure the citizens for your security. They are there for your security, but what are they doing? Actually, they're impacting your performance. They're impacting your mood. That is the same case with security. Encryption will change the text into ciphertext and bring it back into the readable format using the encryption keys. But this process will take some time. And I'm saying it will be so quick, but it affects the performance. So since it affects the performance, that is why the trusted traffic is not encrypted. Within the data centers, within the region, the traffic is not encrypted. Okay, operational security level. For operational security, they use IDS, they reduce insider risk. Insider risk basically means, see, Google also have employees. I don't know if you have read this on social media, professional media, or probably in the news. There was a strike situation in Google office yesterday, and Google had to terminate a couple of employees because they were striking, they were objecting to some Google's decision with respect to the war between a couple of countries. So, how Google is tackling this? This is a risk. If employees are objecting, if employees are revolting to company's policy, to management policy, it's a risk that is known as insider risk because those employees may end up doing something unprofessional, may end up leaking crucial data of the company. So, how Google is managing that risk? So, Google runs a couple of programs wherein Google manages insider risk management. Google uses employee universal second factor use. Google use secure software development practices. So all in all, Google is managing the security of its data center at multiple layers, starting from hardware, software, employees, data, encryption, to provide you a comprehensive security, experience to the end users. What is the last layer of security? What was the last layer?
Erase and destroy data.
Erase and destroy. I'll tell you something that you may not have noticed. If you remember the person who put in the disk and the person who picked it up, they were two different people. And the person who puts the disk never knows the person who is picking it up for the destruction. So there is a wall. That wall has a closet. Inside that closet, I've been to multiple data centers and I've been to one of the Google data center in US. So there is a wall. Inside that wall, there is a closet. So inside the closet, you put the disk that you want to erase or that you want to destroy. And then it will be picked up by the person on the other side of the wall. And these two people will never meet. They will never know, they will never get to interact. Why? Because if these two people can interact, the person who is putting the disk can tell the other person that please take a copy of data. This is very crucial data about NASA, about about CIA or about some business. That is why these two people never get to meet. So the person who is picking up the disk would never know what kind of data is there. And since you don't know what data is there, it is of no importance to you. You will just go ahead and follow the process. So this is what happens in Google Data Center. The other thing that you have noticed is when Joe said that customers can issue their own encryption keys, and At any point in time, we will not look into their data. Why is this arrangement? Why is this happening? Because Google is committed to privacy. So what Google says that we will not access your data unless there is a legal obligation. So what Google is doing that if you are doing business, legitimate business, let's say in US, betting is not allowed. It is prohibited by law. But what you do, you build a compute engine instance in Google region in US and you deploy a betting website on it and you make it available to the rest of the world and you allow people to come and create their account and start doing betting for cricket and for other games. Now the government of United States comes to know about it. Now when they are aware of it, they will probably do some investigation. And if they find that your system is hosted in Google Cloud, they might approach Google and say, we need access to this business data. Now, at that point in time, Google is forced to provide that data to the federal agency or to the police or to FBI. Google will not even talk about it. Google will not even intimate you that we are forced to share your data because it's a national security incident. It's a legal obligation to Google. Other than national security and legal obligations, Google will not access your data, and Google will also not share your data with third parties and outsiders. That is a commitment from Google. Are you with me on this?
Yes.
Another video that I will run now about how big Google data centers are and how Google is maintaining the data center. Okay, let's move on. Next is, if you want to know more about Google Cloud Security, this is the link for documentation wherein they will explain in detail how are they protecting the data centers, how are they putting in place various security measures. All that theoretical information will be available here. Moving on. Then comes open source. Now, see, what you need to understand at this moment is even though you're starting your journey with Google Cloud, cloud is all about innovation. Cloud is all about avoiding any lock-in, avoiding any contractual obligations. Cloud is all about open source. Cloud means cost saving. That's what cloud is all about. This is what it means to business. So Google Cloud is open source. When I say open source, it basically means that all those open source products, solutions, software, technologies, utilities that you were using so far in on-premises data centers or in your servers, in your applications, you can continue to use them in Google Cloud also. Any on-premises solution or any open source solution you can use in Google Cloud. Google Cloud will not interrupt you or will not stop you from using those open source products. First thing. Second, when you host your applications and services in Google Cloud, Google will not lock you. Locking basically means that now you cannot go out. Now your data is with me, you have to stay with me. They will not unnecessarily blackmail you or they will not lock you. So your data is not locked there. At any point in time you feel that you're not happy with Google Cloud services, you can happily exit the contract, terminate the account, and you can move out. Google will not stop you. So Google gives customers the ability to run their applications elsewhere. And whenever you're not happy, just terminate the relationship, which is not the case with Azure and AWS. In Azure and AWS, there are contractual obligations. Unless you satisfy those obligations, you will not be able to get out or terminate your contract or account. So Google has been flexible enough in this case. Okay. Then comes the services that it uses. So Google provides you services, multiple layers of stack. For example, you have Kubernetes, you have operation suites, you have multiple services. Then comes pricing, which is very important. See, you may feel that why are we talking about it? Our job is to support, our job is to provision, our job is to do administration. But think in the long run. Some of you may have probably started your career with Nextern. Some of you may have joined Nextern from outside as a lateral. But do you want to do the same thing throughout your life? Do you not want to grow? Growth doesn't mean switching. If you switch jobs, you may get a higher position. You may get, you know, more package or more compensation, but that will not happen in the long run because there will be a roadblock. At one point in time, there will be a roadblock. You will not be able to proceed further. Nobody will accept your candidature when they see multiple job hops in your resume, or when they find that as compared to the number of years of experience, your package is much more. That is where you will have a roadblock. And I've seen that a number of times with a lot of my learners, a lot of my ex-colleagues. If you want to avoid that situation, you need to be efficient, skilled enough so that your compensation, your year of experience also aligns with that. And how is that possible? That is possible when you think out of the box, when you don't just stick yourself to what you are expected to do in your team. When you think out of the box and when you think of avenues wherein you can contribute more, you can save cost for your management, for your customers. That will take you places. That will make you a good consultant and an architect. And that's where nobody will bother about the number of years of experience that you have or the dollar value that you are available at. Nobody bothers about it. People will want you for your skills and experience, for your skills and capabilities that you bring on the table. That's what you need to do. And that's exactly what I convey to all my learners to focus on so that you can also retire at a very early age. I'm saying, who says that you need to work for 60 years? That happens in government job. The day you feel that you have made enough money, you have enough savings in your account, retire and enjoy your life. So cost is very important here. Cost in personal life, saving, and in professional life at the same time. Saving. So let's understand how Google is putting a price tag to its services and how do you save that money for your business, for your customers at the same time by following the cost optimization best practices. There's a separate domain which is coming out these days, which is known as FinOps. FinOps in Google, FinOps in cloud, and whatnot. It is nothing but a method through which you employ a solutions, automation, or a set of tools to save cost at the end of the day. That's what FinOps is all about. So Google compute products are built per second. Now it says per second. Compute is virtual machine. What does it mean? If I provision a virtual machine for 10 hours, 20 minutes and 55 seconds, will I be billed for 10 hours, 20 minutes and 55 seconds? Does it mean that? Or will I be billed for 10 hours, 21 minutes because 55 seconds is closer to 60 seconds, which is equivalent to 1 minute. So 10 hours, 21 minutes. Yes, that is how you will get billed. It's billing per second billing. Now, second hardly makes any difference to your life, but think of a larger picture. When you have thousands of virtual machines and each second is costing you at least $1. For example, a virtual machine, a largest virtual machine, which has hundreds of CPU cores and terabytes of RAM, will cost you around $300 an hour. $300 translates to $5 a second. What if you have 10 virtual machines? So if Google bills you based on minutes, and if you're running that machine for 10 minutes, 1 second, and if you get billed for 11 minutes, you will end up paying $295 extra for the same machine. That is where Google is billing you per second so that you only pay for the number of hours, minutes, and seconds you have that resource up and running, which is a great thing, which is also available in Azure and GCP. They all bill their compute products by second. However, other services are billed based on usage, which is per minute basis, or some services have one-time cost also. Okay, So Compute Engine offers billing flexibility. Now, Google Price Calculator. This is a great product. So let's see how it works. All you need to do, you just need to type Google Pricing Calculator. This pricing calculator is available for AWS and Azure also. Now, the benefit of this pricing calculator is, let's say you want to deploy an application in Google Cloud, and you have a fair idea of what all services your application will leverage. You want to identify the cost of that service. You want to know the total cost of deployment. That information you can find here. Let's say you want to know the cost of virtual machines in Google Cloud or the approximate cost that you will end up paying at the end of the month. You can just come here. You can type number of instances that you need. For example, I need one instance. You can type what that instance is for. So you can type whether what are these instances for. You can just type the purpose. So I can say this is for POC. Then you can select the operating system, what operating system you need. Let's say I want a Windows operating system, Windows Server operating system. You can select the provisioning model, which is regular. You can select the machine family. Let's say I need a memory optimized machine. This is the machine. And then you can select rest of the information. What kind of disk do you need? SSD I need. Size of the disk I can select 127 GB. Just keep filling all of this information. And after you are done with filling all of this information, at the bottom, it will show you the estimate. It will show you the approximate cost of this that you will pay. So, for example, I keep filling here all of this information that I want to put, then add to estimate, and it will show me the cost. So it says that if you need this configuration, you will get a virtual machine, a POC virtual machine with this configuration in this region. You've selected the region, and this is the cost, which is around the instance cost, which is M1 series cost, which is 5,443, and the operating system cost is around 3,000. So in total, you will be paying the 8,688 US dollars and 52 cents for 1 month. So this gives you a fair idea. You will at least know what you will be paying at the end of the month. You will not get surprises. That's the beauty of pricing calculator. Whenever you want to know the cost, excuse me, for a service, use pricing calculator. I always do that. Before I provision a service, if I want to know how much impact it will have on my pocket at the end of the day or at the end of the month, I will come to pricing calculator. I will quickly select that service and see the cost of it. For example, I want to store some data in Google Cloud. I have got my, so I travel a lot. Now, I'm saying out of 12 months in a year, I am typically traveling 5 to 6 months. These days, I'm traveling pan India, Hyderabad, Mumbai, Bangalore, Chennai, Pune, where most of the IT companies are to deliver consulting and training assignments. But pre-corona, prior to corona, I was traveling across the globe. And while I travel, I take a lot of photographs and videos just for the memory. Now, I've got, so I'm telling you, this is exactly what I do, not a hypothetical scenario. So I've got terabytes of data now. So I've got multiple external hard drives from Western Digital, three external hard drives, 3 TB of space is there, and I have almost exhausted all the capacity. So now I am planning to upload that data somewhere. The same scenario that I discussed on day one, wherein my Google Drive is now exhausted. I'm not able to upload anything in Google Drive. So somebody said that let's use YouTube and upload everything there. That way people can browse and they will not get limited by space. So similarly, I can use Cloud Storage Bucket also. Cloud Storage Bucket is a great service in Google. It's an object storage service. And in this service, I can store petabytes of data. And it also provides me storage classes wherein depending on how frequently I need to access that data, I can pick and choose that class and I can pay accordingly. So let's say I want to use Cloud Storage Bucket. So I can click on Cloud Storage and I can select the storage class. I go with standard. Then the location where I want to store, let's say, since I'm from Delhi, I will choose Delhi. Then total amount of storage. So my total amount of storage is 3072, which is around 3 terabyte. And then I can just select the data transfer. I say I will not transfer anything and I'll just add to estimate. And here I can see the cost that I will be paying. So this standard storage of 3 terabyte per month will be costing me $70. $70 per month I will be paying to store 3 terabytes of data. And I'm assuming that I will access that data every day, all the time. But if that is not the case, and I will only be accessing it once in a month, once in 6 months, as in when somebody comes and I want to show something, I can probably choose another type of storage, which is, let's say, cold line, and look at the cost difference. So when I choose cold line and when I choose the same size, 3072, add to estimate, look at the difference now. Now for cold line, for the same amount of storage, 3072 GB, what I'm paying here, $18. For standard storage, the same amount I'm paying $70. That is the difference. Now, if I say that I will only upload the data and I will hardly use it, probably once in a year, once in 6 months, twice a year, then I will go to another variety, which is archive storage. And I'll select the same size, which is 3072, and add to estimate. Look at the cost now. See the difference. If I store 3 terabytes of data in Google Cloud in standard storage, which basically means that I will be using it almost every day, or I can't predict how many times a day, how many times a month, how many times an hour I will be using it, I go with standard. But if I can predict that I will be using once in a month or twice a month, then I can go with cold line, which is $18. And if I'm 100% sure that I don't want to use it once in a month, I will probably use it once in a year or twice a year, then I can go to archive storage and I will end up paying only $7. Now, $7 is equivalent to some 600 rupees. 600 rupees per month I'm paying for storing 3 terabyte of data. Now, you will still say that it is costly because 3 terabyte of external drive would probably cost me 10,000 rupees, which has a warranty of 1 year. So around 1,000 rupees per month I will be paying in that case. So you may still say that it is expensive, but do not underestimate the additional benefits that this service will give me, which an external hard drive cannot give me. So this is how you can use pricing calculator to estimate the cost of a service before you start to deploy that service so that you don't get surprises at the end of the month. Cloud is all about cost saving. Cloud is not about creating a deep hole in your pocket or burning a hole in your pocket. So use pricing calculator all the time. Get this habit. It will help you in the long run because if you have this habit, you will continue to use this for your customer projects also. And that way you can always educate your customer that, sir, you're using this service. From the monitoring data, I can see that you have over provisioned and underutilizing this service. Or there has been a lot of performance issues and we identify that the service is over occupied, I'm saying a service is over provisioned and under occupied, or vice versa. So Google pricing calculator along with monitoring service will do wonders. That will help you in the long run when you want to look beyond support and want to become a consultant or an architect. Are you with me on this, guys?
Yeah, yes, Ranveer.
Yes, Raghu.
Great. Any questions so far? All right, let's move on. If you don't have any other questions, we are almost done with theoretical part. From tomorrow onwards, we will get into the practical when you don't know what is the cost of that service or how that service is provisioned in the Google data center or what Google data center looks like. You must know the backend of that service also. Okay. Billing teams helps to get budget and monitor usage. So you have billing tools that I will talk about tomorrow when we do the IM, that how do we create a budget? How do we configure alerting when that budget threshold is meeting? how do you download reports or how do you configure automated reports to be sent to yourself or to your admin when that budget exceeds certain limits. And you can also look at quotas. Quotas basically means uh, cloud provides you unlimited resources, but it doesn't mean that you have unlimited access to resources. It basically means that Google will put certain restrictions in terms of the number of resources or amount of resources or services you can deploy. However, those are soft limits. You can increase them as and when you need it. That's what quota is all about. So quotas are allocated at the project level. I'll talk about what a project is when we discuss about resource hierarchy. Let's talk about quizzes. Okay, so let's see who can answer this. And I want all of you to, collaborate here. Even though you got it wrong, it's absolutely fine. You will at least prepare yourself for the certification because these are the questions that comes into the certification. So what is the primary benefit to a Google Cloud customer of using resources in several zones within a region? What benefit do I get if I provision resources across zones? Instead of putting everything into one zone, I'm putting my resources across zones. What benefit will I get?
Fault tolerance.
Okay. Any other participants who feels or who is of different opinion? Probably better performance or more discounts. Anil, Harish,
Yeah,
Dileswar.
it's option A for improve fault tolerance.
Great. I'm glad that you understood the concept of zone. It is fault tolerance because if you put everything into a single zone, what if that zone goes down? Your everything goes down. But if you put it across zones, then you will have improved fault tolerance, which basically means now you have the benefit. If one resource goes down, the other will continue to serve your application. Great. Next. Harish, can you read this question for me?
Yeah, what type of cloud computing service lets you bind your application code to libraries that give access to the infrastructure your application needs?
Okay. So sometimes questions comes in this manner also, wherein you will find the language a bit difficult, but you can always break that into simpler terms. It says which type of cloud computing service, whether it's IaaS, PaaS, SaaS, or public, private, hybrid, lets you bind your application code to libraries that gives access to infrastructure your application needs. So which kind of service provides you infrastructure or provides infrastructure to your application? That's the question. What do you think, guys? Which type of service? Pradeep,
Infrastructure as a service.
okay. As for Kranti, it is infrastructure as a service. What about others?
Infrastructure as a service.
Okay, it's platform as a service then. Understand the question once again. Infrastructure as a service is the right answer when I do not say application core. When I say that I want to build servers. This is here it says bind your application to libraries that gives access to infrastructure your application needs. It's platform as a service, which basically means you are just focusing on your application code, which will be bound to certain libraries. Certain libraries basically means the backend, the middleware on which your code will run underlying infrastructure in some infrastructure. So it's infrastructure, it's not infrastructure, it's platform as a service basically. Infrastructure as a service, it would be if it says that which type of cloud computing service lets you build servers, then it's infrastructure. Okay. Next. Yashwant, can you read that for me?
Yeah,
Yashwant, if you're there.
yeah.
Hmm.
Might a Google Cloud customer use the resources in several regions around the world
Mhm.
to improve security, I guess.
Okay, so we are saying that why might a cloud consumer use resources in several regions? So what it says that why should a customer use services across several regions? For example, I'm using storage from US, I'm using compute from India, or I'm using compute across different regions, storage from different regions. Why? Security is everywhere, guys. It is not that America's regions are more secure as compared to India. No, Google is putting the same security measures everywhere. Those 6 layers of security are equivalent to all Google data centers. So option A
Option D.
is out.
It's option D.
Okay, option D, which looks relevant. If
Option
you
C.
use services across regions, definitely you will be able to bring those services closer to end users, and that will also improve fault tolerance. But there is one more option that I also find very closer to the answer. And you will find this scenario, you will find this situation in the exam, certification exam, wherein you will find 2, 3 options or 2 options very closer to the answer, and you need to choose the most closure one. See, the other that I find very closer is to earn discounts. That is another thing. I'm say, so if you compare cost of compute service, it is cheaper it is cheaper in Americas as compared to Asia Pacific or as compared to Europe. Compute is cheaper there, and I've seen most of the customers using it, even though they have businesses in Europe, they have businesses from Asia Pacific, but they are deploying compute in US because compute comes at a greater discounts in US. So we have 2 options, and the right is the D1. Why this is the right answer? Because it says that why might a customer use resources in several regions? So whenever it is about several regions, it is either cost or it is either fault tolerance or end user experience. So if both options are there, use fault tolerance. If one option is there, then use one of these options. Okay, next. Give me a moment. All right, let's move on. Next, interacting with Google Cloud. It's a small module that we will be able to complete in next 10 minutes. And tomorrow we will be starting with hands-on. Tomorrow we will be starting with identity and access management. I want all of you to have your trial account ready, active, so that you can start doing the hands-on lab. In 2 hour session, we'll primarily focus on an hour of theory, an hour of hands-on, and then I'll give you some home assignments also. Not very lengthy assignments, small assignments that will take not more than 15-20 minutes. Question is, how do we interact with Google Cloud? So how do we interact basically means what are different ways using which I can communicate with Google Cloud. I can uh, give instructions to Google Cloud. I can manage my existing services in Google Cloud. I can deploy new services in Google Cloud. That's what interacting with Google Cloud is all about. So there are 4 ways here. Our focus in this training will be on first 2, which is Cloud Console, Google Cloud Console, which is a web user interface. It's a browser-based interface. You need a browser, either Google Chrome, Mozilla Firefox, Safari, Microsoft Edge. So on the browser, you type console.cloud.google.com and you're able to access the console. This is also known as GUI, graphical user interface, which is more user-friendly. Second, Cloud Shell and Cloud SDK. Now, Cloud Shell and Cloud SDK is also part of the console. You can use them separately. You can use command line, which is nothing but DOS, and deploy Google command line interface there, or you can directly access it from Google Cloud Console. Then comes third, which is REST-based API. If you are a developer, if you are into building and deploying applications, and you're using development platforms like Microsoft Visual Studio or .NET Framework or Java or any middleware, JBoss, and you want to communicate with Google Cloud so that you can authenticate and authorize so that you can push or pull something from Google Cloud, which is known as API-based operation, application programming interfaces. So you can also use REST APIs to communicate with Google Cloud. Fourth is mobile app. Google also has a mobile app that you can download from Play Store, Android, and iOS Store from Apple. The capabilities are very limited. I would not say that it will provide you similar experience, console equivalent experience. No, but at least you will have some capability. For example, you can manage a compute engine. You can quickly shut down compute resources. You can in fact provision cloud storage bucket. You can manage up to a certain extent. So not everything is possible, but 30 to 40% capabilities are available in mobile app. And this mobile app, Google is primarily improving a lot. The mobile app is also available from AWS and Azure. However, I have all the three mobile apps installed in my mobile phone because I have accounts in all the three clouds and I do provide services and training. I have personally experienced Google improving its mobile app significantly in the last couple of months or probably in the last 1 year. I have not seen that improvement in AWS and Azure. They are probably not focusing on improving the mobile app because they may not think that businesses would use mobile app to manage resources, which I personally think that if there is a capability, it has to be advanced. It has to be improved. So try yourself. Probably today, only download mobile app for Google Cloud, authenticate using the credentials that you used for creating the free trial, and then see what all capabilities are available. And if you are stuck, if you have any questions, ask me tomorrow, first thing in the morning, first thing when we start the session. So these are my options. Now the first option, Cloud Console, Cloud Shell, and Cloud CLI. This is your Cloud Console, console.cloud.google.com, wherein you will see GUI, wherein you will see resources in the form of tables in some order. The same information is available from Cloud Shell, which is part of console. You can create a Cloud Shell, and that Cloud Shell will use CLI commands, command line interface commands that you can type. And as a result of those commands, you will be able to execute an action. That action will produce a result or an output, and you will see the information. For example, with this command, they're trying to list all the compute instances. So in the console, you directly see, you navigate to compute engine and you see all the compute engine instances. In the CLI, you type this command and it will show you all the compute engine instances. The same thing. The only thing that you need to do is to remember them. There is a syntax, there is a logic. If you practice more, you will be able to understand that logic, and then you don't need to remember all the commands. By hit and try, you will be able to manage it. All the three clouds provide the CLI and shell option. Okay, so it is just showing that how do you get it. Then Cloud Mobile App, they have a mobile app, as I told you. And with this mobile app, you can manage your billing, you can manage apps and app engine, you can manage virtual machines and databases, you can visualize your project with a customizable dashboard. So install it and see it for yourself. That's it. So this is about the interacting with Google Cloud. Now we will do certain labs, but since we are only left with 10 minutes, I will probably not start with the lab part. We will start it from tomorrow. So tomorrow, the agenda is to discuss the identity and access management service in Google Cloud, which is one of the core services of Google Cloud. Thank you. You have a great rest of the evening ahead.